8th graders, if you are watching this, you are taking this test from home. So that means you were either absent the Monday, Tuesday, or Thursday, Friday that you guys were supposed to take this in class, which we did on paper for part of it, or you guys are DLI and you're doing it from home anyway. Okay, so with that being said, a little reminder for you guys, all missing work for the thermal energy unit needs to be turned in by Friday at 3, so that's this Friday. Okay, we'll be done with all of our tests for the thermal energy unit and are going to be moving on to the next unit this week as well. So any grades or assignments from the thermal energy unit are going to be closed down on Monday. So make sure you guys have all of those in and finished. After that, you guys won't be able to open them or finish them, and the grades will be put in as incompletes in Power School. Okay, so moving on. So you guys who are doing this at home, you guys are going to do this first part of the test here in these next 2 slides. Okay, so on the first slide we have some directions for you. The model below, or on the next slide, shows 2 different objects, a top and a bottom, and those are your before objects, each with 6 molecules of different kinetic energies and different temperatures. Use the 2 after boxes to predict what would happen if those 2 objects were pushed into contact with each other, and also that they're allowed to reach equilibrium. So let's go ahead and take a look first at the model before I jump you through the steps. So you guys can see here's object 1, here's object 2, and we're going to assume that these 2 objects are going to be pushed together, or maybe they have just been pushed together, but yet they haven't been held together long enough for any energy to start transferring yet. Okay, so, and then you guys have here, we're going to have that model the same 2 objects after they've reached equilibrium. So that's kind of what the after means, is they've been pushed together, energy has been allowed to transfer back and forth, and now they're at equilibrium. So you guys are going to be modeling that. Okay, so let's go ahead and walk through the steps. You'll notice that the steps are little check boxes. So as you guys move through them, please check them off so you know that you've accomplished it. It's silly to lose a point because you just didn't read or you weren't careful and you just missed a step. Okay, so first one says, of the 2 before boxes, circle the one that has the highest kinetic energy. So you guys are going to come up here and you're either going to circle this one or you're going to circle this one. So that's going to be your first step. Okay, come back, check it off. That's worth 1 point, is circling the correct box there. Okay, worth another point, in the small box between the 2 before boxes, draw an arrow to show which way the energy would transfer, if there will be an energy transfer, or draw an X if no energy transfer will occur when the objects come into contact. So in this box right here, you guys are either going to show a down arrow, an up arrow, or an X. Okay, those you'll actually have to draw in here. So if the energy is going to transfer from this one to this one, you'll do a down arrow in that box. If it goes from the bottom one to the top one, you'll do an up arrow in this box. Or if there's no transfer at all, you'll do an X in that box. So again, remember those 2 before boxes are right before they're pushed together and really have a chance to allow energy to transfer. So which direction will they transfer? Make a prediction in that box. Okay, moving back, check that off. That was worth 1 point. Next one, in the 2 after boxes, draw 6 molecules in each and label them with a 1 to 5 to show each molecule's final kinetic energy. So that one's a slightly different from the instructions. Instead of drawing, you guys will go back to your cursor, and all you'll need to do is click and drag whatever molecules you guys need here to get them in the correct spot. So remember, you need 6 for the top box and 6 for the bottom box, and all 12 of those little circles should have the correct number that designates the average kinetic energy for those 2 boxes. Remember again that this little system marked after is after those 2 have had a chance to really transfer energy and they've reached equilibrium. So you got to think about really what equilibrium is. So again, 6 molecules up here, 6 down here, and then they should have the correct number in them to reflect what the kinetic energy would look like for those 2 boxes at equilibrium. Okay? Again, that was worth 2 points, so you guys can go back up, check that one off. Next one, fill in the thermometer to show the final temperature of each object. Very similar to what you guys just did, where you guys will be clicking and dragging the thermometer. So you have 2 thermometers to click and drag. So you guys can grab 2 different thermometers, click and drag where you need them to be. But again, it's 2 points because you need a thermometer here and a thermometer there. Okay, so make sure you guys fill in those thermometers. And then again, you guys have the 6 molecules with the correct numbers. Okay, and go check that off. And then finally, draw an arrow or an X in the small box between the 2 after objects to show the final energy transfer. Okay, so remember these two boxes have reached equilibrium, so is the energy transferring from this box to this box to this box, or is there no energy transfer at all? So do one of those symbols in this box here. Okay, and then you can go back, check it off, and move on to the next part of the test. So you guys have a little bit of a quiz. I think there's 22 questions on it. We'll double check, 20 questions. And you guys will right click this link right here. You'll open it up. And you guys will complete this in Microsoft Forms. Make sure you guys also submit it in this Forms as well. So you guys can see most of it is multiple choice. Really, I'm not going to go through much of these. I don't think there's any I have to give you guys any information on. For the one you guys have to calculate an average, you guys should be able to do that with mental math. You don't need a calculator for that, but you guys can also pull one up on your computer if you want. These are all pretty easy. So this is the only one you guys have to type to explain your answer. So it references the question before, which was question 11, which has a lower thermal energy, an 85 degrees Celsius teapot, which is 100 milliliters large, or an 85 degrees Celsius cup of tea, which is 300 milliliters. You guys will make your selection there, and then you'll explain why you made that selection, or why that object has the most thermal energy. And then which system is at equilibrium. You guys can work through all of those. Here's looking, I think that's really it. I think for the most part, you guys can read through those and do it yourself. And then again, when you're done, make sure you guys hit submit. Hand it in there. You guys can come back here. You are done. Make sure you hand this in just to show me you're done. And obviously, since you guys are DLI or working from home, I will need to grade this part of the test. So again, make sure you guys hit hand it on this so I can get it all graded for you. I hope you guys are having a wonderful day. Please let me know if you have any questions, and I'll talk to you soon.